Day 298 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 40, combination sum 2. The difficulty level is medium, but don't worry because we're going to keep the solution as simple and easy to understand as possible, y'all. But before we get started, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description and get you some. Now let's see what the question says. Question says, given a collection of candidate numbers candidates and the target number target, find all unique combinations in candidates where the candidate number sum to target. Each number in candidates may only be used once in the combination. The solution set must not contain any duplicate combinations. All right, y'all, that sounds simple enough, but let's go ahead and take a look at these examples so we can make sure that we are answering this question correctly. So in example 1, we have the input candidates equals an array of integers 10, 1, 2, 7, 6, 1, and 5. The target is 8. The output is the different combinations of elements that we can use to reach a target of 8, right? So the first combination is we could do 1, 1, 6. So we could take this one, and we could take this one, and we could take this 6, add them all together, and we'll get 8. The next combination is 1, 2, 5. So we could go 1, 2, and 5. Now it's important to see that we cannot, in this case, we can't just use this one and this 2 and then 5 and then try to do another combination with this one and this 2 and this 5. We only need 1, 2, 5 once. We don't need to have duplicate combinations. So even though these are different ones or these are different ones and hold different places in memory, the combination is still the same. So we have to remember that as we're coding. So we realize, or so we make sure to not use the same combination twice, even though we may have two ones or two elements in the array, in the input array, that would allow us to use two different elements in memory, but it would be the same combination. So that's just something to keep in mind as we're writing the code. The next combination is 1 and 7, so we could take a 1 and a 7. Once again, we can't do 1, 7 twice. We can't just take this 1 and 7 and then take this 1 and 7 and have two different combinations. We're only doing 1, 7 one time, right? It's only one combination of 1 and 7. Then the last combination would be 2 and 6. So it'd be this 2 right here and this 6 right here. So boom, let's go ahead and look at example 2. So in example 2, we have the input candidates equals an array of integers 2, 5, 2, 1, and 2. This time the target is 5. The output is the first combination is 1, 2, 2. So we could take a 1 and 2 of these 2s. That'll give us 5. And then we can just take 5 by itself as well, and that will get us 5. And once again, see here, we have 3 2s. So, but in the output, we still only do this combination once, 1, 2, 2. We're not switching, we're not using these 2 2s for one combination and then trying to use these 2 2s for a second combination. Doesn't work like that. We're just using we're just doing one combination of those elements, right? No matter how many times those elements may appear in the array, in the input array. So now that we understand the question, y'all, let's get into the fun part, the actual solution. And the solution is not that difficult, y'all. We're going to use some backtracking to solve this problem. So I hope you're excited about that. Now, the first thing we need to do is we need to create a frequency dictionary to count the occurrences of each candidate. So in order to do that, we're just going to declare a variable. We'll call it freq. And then we'll set that equal to a dictionary of integers. So we'll say int, int. Come outside those square brackets. And we're going to open up the parentheses. Inside of those parentheses, we're going to say candidates dot map. Open up the brackets. We're going to open up some parentheses inside those brackets, and we're going to say $0, 1. Boom. Then we're going to come outside of those brackets, but still inside those other parentheses, and we're going to say unique keys. Then we're gonna say colon and the plus sign, just like that. So what this right here is going to do is this is going to transform each element in candidates into a tuple, essentially making that each number has a count of 1. So this is going to be a tuple of each element in the array, and it's going to keep count, but we're just going to start with a count of 1. And this right here, unique keys plus right here, is this is going to keep track of how many times we see each element, right? So this is going to, each time we see a duplicate, we're just going to add that so we could keep track of how many times that element appears in this array, right? So just like this, if we see a 1 here and a 1 here, then the value will have this will be a key of the 1, then this will be a value of how many times that 1 appears. So now we need to extract and sort unique keys, and which are the distinct numbers in candidates. So in order to do that, let me see. Hold on, y'all. Hold on. So in order to do that, what we are going to do is we are going to say let keys equal freak. Oh, excuse me, not freak. Let keys equal freak. Yeah, let keys equal freak. Sorry, dot keys. So it's gonna get the keys from freak. Then we're gonna say dot sorted. Boom, and open up the parentheses like that. Now we need arrays to store partial combinations and final results. So in order to do that, we're going to declare a variable called partial, set that equal to an array of integers, come outside of that array of integers and put 2 parentheses like that. Then we're going to declare another variable called result, and that is going to be a 2D array of integers, because as you can see, this is going to store our output, and as you can see, our output is going to be a 2D array of integers. So you can see it's going to hold an array of arrays, basically. That's what a 2D array is. So it's going to be a 2D array of integers, come outside that, and we are going to initialize it with 2 parentheses like that. Boom. Now we need to we need to create our backtracking recursive function that's going to find the valid combinations for us. So in order to do that, we could just come right here, declare a function called backtrack, open up the parentheses. We're going to say underscore start index colon. That's going to be an integer. Excuse me. Then we're going to say comma. Then we're going to say underscore target colon. That's going to be an integer as well. Then we could come outside of these parentheses, open up our brackets, and let's get started. So first thing we need to do is we need to start. We're going to say for, open up the parentheses, I, comma, key, in. So come outside that, we're going to say in keys, open up the square bracket, start index, dot, dot, dot. Boom. Then we're going to come outside of that, and we're going to say dot enumerated. So and the enumerated, that's going to get us the value and the index. Now we only need to use keys with the remaining occurrences. So we're going to come underneath that, and we're going to say where freak square bracket key exclamation point, because it's optional, so we could just unwrap it like that with the exclamation point. Then we're going to say is greater than 0. Then we're going to come out after the 0, we're going to open up our brackets. Now we need to see if the key is greater than the remaining target. That means we can stop the recursion. So in order to do that, we could just use a guard statement. We're going to say guard key is less than or equal to target, else we're going to open up the brackets and return, just like that. Now we need to add the key to the current combination, so we could just add that to partial, because remember, partial, this is when we're building up our combinations. So we'll say partial dot append, open up the parentheses, key, just like that. And if the current key matches the target add it to the result. So we could just come right here. That's like we could say if key equals target, boom, we could just add it to the result by saying result dot append, open up the parentheses and say partial. So that is similar to if we have a case like this where 5 equals target and we just need to add that 5, we don't need to add any other elements. Then we could come right here and we could say else, open up the bracket. So otherwise, we're going to decrement the frequency and continue searching. So in order to do that, we just say square bracket key, come outside the square bracket, exclamation point, minus equals 1. Boom, come underneath that, we're going to say backtrack, which is the function that we're working on now. We're going to open up the parentheses, we're going to say start index plus I, comma, target minus key. Boom, just like that. And then we need to restore the frequency after backtracking. So then we could just come right here and we could say square bracket key, exclamation point, plus equals 1. Boom. Now we need to remove the last added element to explore other possibilities. So we could just come right here and we could say partial dot pop last. Boom. Parentheses at the end too. Now we need to come right underneath all of this and right here. And we need to call our backtracking function from index 0 with the target value. So in order to do that, we just say backtrack, open up the parentheses, 0, comma, target. Then we're going to come underneath that, and all we have to do is say return result. Boom. Now that should be all she wrote, y'all. Let's give it a run. Make sure it runs properly. Let's see. Okay, we got an error. See where that error is at. So the error's up here. So let's see what we did wrong here, y'all. So it says incorrect argument label. What we do wrong, y'all? What did we do wrong? Should unique keys with, maybe that should, sorry y'all, should be unique keys with, I think. Let's see. Oh nope, that didn't do it. So let's see y'all. Let me see y'all, what is going on with this. Sorry about that, y'all. We're gonna figure it out though. We're gonna figure it out together. I'm trying to see. Let me see. What's that? My bad, y'all. What is going on here? So we got the dictionary. And then we got the candidate. Did they make sure I spelled everything wrong? Candidates.map. Oh, sorry. No, I thought I found it, y'all, but nope. Not yet. I wonder, could it be the space? I don't think it's the space, though. What's going on? What is going on here, y'all? Let me see. Oh, let me see. Unique queuing. Excuse me. Let's see if this works. Unique queuing keys with. What the? Okay, so I guess that fixed that, but we still have another error. Okay, boom. So, sorry, y'all. So, yeah, this should be unique queuing keys with, not unique keys. Sorry about that, y'all. So now, let's run it and see if that works. Let's see. Oh, and it's accepted, y'all. That's why syntax is so important, y'all, because you never know. One little mess up could mess up the whole code, y'all. So make sure y'all fix this. It should be unique queuing keys with. Sorry about that, y'all. So now let's go ahead and submit it. Make sure it works after we submit it. Let's see. And it's accepted, y'all. 0 milliseconds beats 100% of users with Swift, y'all. That's what I like to see. Those are some good numbers right there. Now, with that being said, make sure y'all get one more look at the code. One more look at the code. Read it, learn it, love it. That's the top half. This is the bottom half. And I hope y'all learned something today. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.